And this code I'm going to use is going to be a collection of people. So I'm going to bring that up. So let me copy this over to where I need the files. So this is going to be a class called person. So I got a class person, I got a name, a gender, age, constructor that initializes these values, and getter returns all of those values, and toString simply helps us to print it. So not a whole lot in a person. Then I'm going to create a person. So the create person function or method, all that it does is it just creates a collection of people. There are a bunch of people, different gender, different age. Some of them share ages, some of them share names, some of them share gender. Let's go ahead and start playing with something. The first thing I want to do here is get in uppercase the names of all female older than 18. So that's the function I would like to implement, right? So we know how to do this in an imperative manner. How would we do it in an imperative manner? We'll first create an empty list. We'll loop through every element in the collection, right? We will check if that is a female object. We'll check if it's an object older than 18 years old. If it is, we'll add it to the list, which was originally empty. When we finish all, loop through it, we say, here's the result, take it, right? That's the way we would write it. That is called imperative style of programming. That's what we normally do. Let's see how we're going to do this in more of a functional style. So we're going to say people, first of all. So list person people equals create person. Now I can start with this and say, well, now that I have a list of people, I'm going to say output. Well, actually, I can just loop through and print it. So I can say people dot stream. So what in the world is a stream? Think of a stream for now as a very fancy iterator. So so we know what iterator in Java is, right? Iterator has two functions, has next and next. Well, has next and next, right? Yeah, or has more and next. Well, this one is going to be a lot more fancier, has some very nice specialized functions available to us. So what am I going to do with the stream here? I'm going to say, first of all, filter, and I'm interested in only the female persons. So person, and person in this case, dot get gender, and equal to gender dot female, and then dot filter person dot get age, and in this case I'll say greater than 18, and then finally I will say we want to do a conversion, right? So map person get name, and then do a map again and string to uppercase, and then once we convert it to an uppercase, it's a names all in uppercase, I'll say collect, and we will put it into a list eventually. So that is going to be the operation we perform. And once I do this, or now that I'm interested in getting all the names, we could even print it. So we could say dot for each, and we would say system dot out colon print line, and that would print the results. So it turns out two Sarahs and Paula are the female older than 18 years old. But what are we doing in this particular code? If you look at this code, what we have done here is we have said, given collection of all the people, only filter out the female in the group. So this is a filter operation. And once we filter the female in the group, then we are saying only filter out among them those that are older than 18 years old. But I don't want the people anymore. I only want their names. And now that I went from a collection of people to collection of names. Now that I have the collection of names, I want all the names in uppercase. Now that I have all the names in uppercase, I just want to print it. So you should get a feel for this transformational aspect. You go from one particular view to another, to another, to another, and you arrive at this destination, right? That's a transformation that you have to get comfortable with. And you want to start thinking in a declarative rather than imperative style. In imperative, you're sitting there and doing a lot of different work, whereas here you step back and say, I'm going to take this and transform this and transform this, and you're looking at the transformational sequence through it. That's basically what you're doing in this particular case. So given this, that's basically an example of how we would do this. And I didn't quite do it imperative. I talked about it, but we did it functional. But what in the world is a stream really? First of all, think of a stream as an oh yes. Yeah. That's a really good question. So the question is, thanks for asking that. So the question here is, hey, can I not combine 24 and 25? Can I not combine 22 and 23 for, well, 23 and other 23, right? So the point really is, why can't I combine the filters together and the maps together, right? Now let's say we do this. What's going to happen? When I look at this code, that one filter is going to do 2 operations, and that one map is going to do 2 transformations. The code is going to look a little bit more complex to read than it is now. Remember one feature we really like in software. It's called cohesion. Cohesion is where a piece of code is small, focused, and does one thing well. If you look at this code here, every single line is cohesive. You can put your finger on any line and say, what does that do? You're going to have a single answer for it. What does that do? It tells you if it's a female or a male. What does that do? It tells you if they're older than 18. What does that do? Guess their name. What does that do? It gives me a name in uppercase. If I combine them together, then it's no longer a single, it's going to be multi. Now, cohesion is a good property to have. Now look at the beauty now. Because I kept them separately, if I come to you and say, you know what, I don't care that they are female or not, I only want people older than 18, I remove one line of code, and it's easy, right? It's easy to remove that one line than to remove a condition between if I'd merged them together. Or you say, well, yeah, sure, but I also want to make sure I only have people whose name is 4 letters long. I'm going to go to the sequence and insert a filter in between. It's easy to insert and remove a filter than to go and change an existing series of filters, right? Cohesion is a very important property. Now, obviously, one reason why you would be tempted to say what you said is you have kind of a feeling that this could be poor in performance. But actually, the evidence is the contrary. What Java actually does is it merges things together. It's called a fusing, and we'll talk about that a little later, how this can bring it up. Yes, please. The question is, does it do a null check? Well, got to be careful. Null is always a problem. If there is an element which is null in the collection, you will fail. You will fail with a null pointer exception. If the collection itself is empty, that's not a problem. So if there is possibility of null, which is really a bad idea in the first place, but if there's a possibility of null in the collection, you would then have to write a filter that says, if the person is not a null, then continue doing more things. So if there's a possibility of null, which is a bad idea, first place, you don't want to have data which is so bad, cleanse your data. If there's a possibility of null, do the null check. So that's your responsibility still for you to do that. So given this, that's basically, so what is this really? It's an abstraction. So what that means is, a list is an ordered collection, a set is an unordered collection. Collections really are even though you may have an interface for a collection is still a concrete representation. It's a list versus a set versus a hash map, right? Over here, though, a stream is not a collection. A stream is a pure abstraction. Think of a stream as a view of the data. And I'll talk more about this view representation in a minute. It is non-mutating. It does not mutate any data that's coming in. It only performs transformation, not mutation. I said it's a view of the data that transforms and goes through a pipeline. What does it mean it's a view of a data? What that means is it is going to take this data and it's going to arrive at a destination But anything through the pipe is not stored physically as a collection. So what that means is, if you go back to this code example here, you are starting with a list on your hand. If I were to say collect, and I say to list here, now you can look at this code and say, how many representations do I have on my hand? A naive way to look at this is you could say line 21, 22, 23, 24, 25, and you can keep going like this, right? Then you could say there are 6 collections or 7 collections, but that's a wrong answer. What you have actually is exactly 2 collections. The source collection and the destination collection. Everything in between is a pure view. You don't physically have that collection anywhere in memory that you can go and touch. And that is one of the beauties of Java 8, is the efficiency that comes with it. So they take this source collection and they directly put it into a destination collection without creating intermediate collections. If you're programmed in a few other languages, that's not the way it works. In some of those languages, you end up actually creating middle collections over and over. That's not the way Java 8 does. Java 8 is pretty darn efficient to go from the source to the target in one shot without anything intermediate. So this is a view. So it's kind of like if you are passing a stream of data, you start at the source, you end up with the destination, but the middle is pretty fast. You don't really have a way to collect it and take a look at it, right? That's basically an abstraction. That's what you're dealing with. So you're going through this pipeline pretty rapidly, and you don't have any representation in the middle that you can store away and examine the data. You don't have that quite easily. How do you really use them? First of all, you raise the collection, write the stream, compose the operation, and you land back. Let me explain what that really means. You're on a concrete collection, a list, a set, a map, whatever that could be, right? You raise to a stream. Now you're in the higher level of abstraction. And you write the stream through all this pipeline and composition of operation. And when you think you are done, you then come down to a concrete representation. So visualize in your mind, you are here in a concrete type, you raise up to a stream, write the stream, and eventually land back on a concrete. This view is very useful for a couple of different reasons. Take an example for a minute. I fly a lot, so a lot of times my examples are flying examples, but also is a nice metaphor to compare. Well, my home is near Denver, Colorado. That's where, what I call as home. But I spend a lot of time in Oslo, Norway. I'm there about every 6 weeks. So a very ideal situation, if at all, would be to take a flight from Denver, Colorado, all the way to Oslo, Norway, and that would be really perfect. And I could leave the airport, maybe about 9.5, maybe 10 hours later, I'm in Oslo. That would be great, right? So I could take this flight in 10 hours and I've reached my destination. But the reality is that almost never happens. I would leave home and I would fly to Washington, D.C. That's a good about, give or take, 4 hours flight. I would land in Washington, D.C., and typically I wait in D.C. for about 2 hours, potentially more. I would take a flight from Washington, D.C. to Frankfurt, which is another 8 hours of flight. And I would spend typically about anywhere from 2 to 6 hours in Frankfurt, depending on the time. And I would hop on and take another 1.5 to 2 hours flight to Oslo. So what happened was, what could have been a 10-hour flight typically ends up being anywhere from 16 to 20 hours of flying, right? You know this pain, right? Now think about this for a minute. If I take a very direct flight, I don't lose much time, but every time I land and take off, I typically lose about 3 to 4 hours minimum. Now think about streams for a minute. If you are in a collection, you raise to a stream, you keep going in one shot, and then you land into a collection, concrete collection. You have not taken a toll in between, right? But let's take a little bit of a scenario, a slightly different scenario. Let's say he has a function, And his function takes a list and returns back a list. And his function takes a list and returns a list. And her function takes a list and returns a list. So I'm the guy who wants to use all these three functions. So what am I going to do? I'm going to take my list, send it to him. Internally, he could be using streams, but he then puts it back into a list and gives it to me. That's Washington, D.C. right there, isn't it? Then I take this list and I call him. He uses stream internally, puts it back into a list, returns to me. Well, right there is Frankfurt. Then I call her function. She uses list internally, puts it back into a list, and now notice what I did. I went from a list to a stream to a list to a stream to a list to a stream. That was a complete wasted performance, isn't it? But let's think about it. They three get together and say, let's refactor the code. So what does he do? He takes a stream and returns a stream. And so does he, and so does she. Now I take my list, raise it to a stream, and I call his method. He gives me back a stream. I pass my stream to him. He gives me back a stream. I pass my stream to her. I get back a stream, but I'm still up here in the air, right? I've not landed on a concrete type. And what's the benefit? I've not really done any work yet. Because real work happens when you know what the destination is, but I've not told what the destination is yet. So now I have a choice. After calling those three functions, I got a stream on my hand, and I can say, well, you know what? I'm done. I'm going to put this back into a collection, and I can do all that work. Or I can take this further and say, not done yet, and I can call his function. And his function takes a stream and can return a stream again. I can keep it floating, right? So the benefit is I'm postponing evaluation until I finalize where to put it. Make sense? So here's another way to think about it. I'm a huge fan of pizza. Well, there's got to be a place where all this belly comes from, right? I love pizza. But I'm also a full vegetarian, which means it's very restrictive what I can eat. So how do I get absolutely a great vegetarian pizza? Well, I've got a pizza shop very close to my house. It's one of my most favorite pizza shops. I would go in there, I would say, I want a pizza, please. And what they would actually do is they would take the crust, they would put the sauce on it. And this makes me already hungry, sorry. So they'll put a sauce on it, and then I get to tell them what vegetables I want to put on it. So they put all the vegetables I ask for, specifically. Then they put cheese on it, and then comes the fun part. Right about now, they would wrap it, and they would give it to me and say, here you go. What did they not do? Bake it. They haven't baked it yet. You got the point, right? You think I'd eat that pizza? No, right? So I would bring that pizza home, and guess what? I get to unwrap it, and not only am I a vegetarian and I love pizza, I'm a guy who loves spice a lot. So bring on those jalapenos, right? Slap more on it. Make it more spicy. And I've still baked it. And at this point I have a choice. I can keep it around, maybe in a refrigerator for some time, or I could send my family to go get more spices if I want to add more to it. But eventually, where does it go? It goes into the oven for baking. But until it gets baked, I can eat it. But I can postpone baking it as much as I want to, well, within limits. That's exactly how programming with streams feels like. You raise it from a concrete, write your stream, but don't get down until you're sure you want to commit. What's the benefit? Until you commit, none of that work actually gets done. Let's take a look at it, how that's true. This is where the real power comes from. So let's take a quick look at how that works. So if you go to this example here, notice we started with this stream right here. We are landing back into a list in the very end. So for this to work, I'm going to say stream.collectors.star, and this is going to become the collectors to list method. So now if I go back and run this, well, it's running through, produces the result, and I'm going to simply say here output done. And you can see it says done. However, I'm going to go to the person, and in the person I'm going to say in the get age method, I'm going to simply say over here, output called for, and I'm going to say name. So now if you go back and run this code, this shouldn't be surprised. It is called for Sarah, Paula, and Jill, and it called for all of them. It called the getAge method. Why did it call getAge only for those people? Because those are the only female, right? It did not call it on the male. This partly answers your question, right? Whether I combined it into one or kept them separate, that was not a big problem, right? So because it never executed that function for male, it only executed for the females. However, there is one beautiful thing here. Notice when I ran this, it did all that work, and then it said done. Please. A little louder, please. Unfortunately, Java 8 doesn't give you ability to go through a map. They allow you to go through a map's key or map's value. But you can do it on a set if you want to.
It does not mean the collection map here? It doesn't mean the collection in the map?
When you say map, oh, you're talking about the map function.
Yeah.
Okay, wait. So, repeat your question for me.
So it is called 4 times the getAge, right? If you go with the same philosophy, the map is also considered as a collection, right? Like
no, those are not collections. They're abstractions. They're views.
Okay.
So what it's doing is it's calling that function on the elements in the original collection. There's only 2 collections here, the start and the finish. There's nothing in between. But it's got to do the work. But there's no physical collection. There is no cities to land over and over. You start here, you end here, one shot, right? You perform the transformations. You don't say, go from this collection to this collection. Are you done? Are you all arrived? Now let's go from here to the next one. It doesn't hop everybody through it. It simply says, here's the start, here's the end, do it in one shot, right? Yep.
You said you can stay with the stream and postpone the processing.
Yes.
But what if the collection changes in the meanwhile while you're still staying in the stream level?
So the question is, what if the collection changes? Well, one of the core tenets of functional programming is we program with immutability. So we don't want to rely upon things that constantly change around us because it becomes really problematic. But specifically in this case, the triggering of the computation happens only when the destination is called. If you never call the destination, you didn't do the work. So all it cares about is when you start performing the transformation, that's when the collection shouldn't change. So let's define 3 time frames. Time up to when you never really called it. It doesn't matter what happens during that time. You can keep changing it. There's a time when you start working with the transformation, right? You're going through the pipe. When you start going through the pipe, there's a time between when you start and the time you finish. With me? Once you finish, you don't care what happens after that. But during this time, what will happen in traditional Java, when you are iterating, you go and change a collection, what's going to happen? Concurrent change exception, right? Concurrent modification exception, same thing. So you want to make sure it doesn't change the minute you start iterating to the minute you finish iterating. That's the key.
But if the intermediate stream which you have, suppose you want to pass it to another function which takes a stream,
yep,
and you also pass it to a third method.
Cannot. It's a one pipe. It's not a tributary, right? So one stream. You start and you end. One path. You don't take him around a trip.
So it's not a variable where you can save the intermediate stream.
It is not that stream that's going to go through branches. You start, you go where you want to. You can alter the path, but you cannot split it.
But can I assign it to a variable and hold the intermediate state?
Yes, you can. But you have not committed to it yet. No work is done.
But then after that variable, I can pass to functions which times.
Yes, you can, but not to 2, but you can pass it to 1. Yeah, don't send it to multiple places. You can keep going in one direction. It's a composition. You don't say, here's a stream. I'm going to send it to him and then send the original to here. No, you cannot. If I send it to him, continue from what he gives you. Right? Am I making sense? You have a variable. You send it to him. You're done. Don't send this variable to anybody else.
Why not?
Sorry?
Then it's not.
Sorry.
If it's
Only one person can speak at a time. Go ahead. What happens if sorry, he has the mic. Concurrency doesn't work. Go ahead.
In a typical variable, like when you're processing like a list or something.
Once you have a variable, you send it to a function. Do not send the same variable to any other function, because a stream should never be reused.
Oh, it should never be reused.
That's what I'm saying. You cannot split it and send it to multiple places. One line stream. You had a question.
What happens if you do?
Bad things happen. If you are telling the child, sweetie, don't cross the street when there is traffic. The child says, what happens? You don't tell the child, try it. You say, sweetie, I love you dearly, don't do it. No, the compiler, I mean, come on. When you're trying to cross the street, does the compiler come and tell you? They say that was a victim, right? Okay, so let's look at this for a minute. So notice in this case, it ran through that. However, watch this very carefully. I'm going to comment this line out. Just that line, only that line. Now what have I done? I started here, transform, 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 transform. What do I have on my hand at this moment? A stream. What have I not done to the stream? Landed on a concrete type, right? So what's going to happen is the question. You all know the answer for it, because you know whom I'm talking about at work, right? You know this person at work? What does the person do? Comes in the morning, sits down at the desk, looks around and says, hey, where's the boss? You say, oh, the boss is sick today. And the person says, yes, I don't have to do any work today. You know who I'm talking about, right? That's this dude. So notice now, I did not commit to the collection. I'm like, done. I don't have to do any work. Right? That's exactly the laziness. Now you know why not to commit. As long as you don't commit, they all are lazy, right? I don't have to do the work. Not yet, not yet, not yet. Now you say, all right, I want the result. Okay, now let's do the work. But they only do minimum work to get you the result. So here's another way to think about it, right? Do not think about this as where it starts with the list of all the people. How many people do we have here? 1, 2, 3, 4, 5, 6, 7, 8 people, right? It doesn't start with 8 people. For the sake of argument, let's say half of them are female. It does not go from a collection of 8 to a collection of 4. It doesn't do that. It doesn't then go from a collection of 4 to, let's say, a collection of 3, for example. Then it doesn't go from a collection of 3 to a collection of 3, where it's a collection of people to a collection of names. Logically, it is doing it. But physically, look at it very differently. It starts up here, and it says, take one collection, one element, run that one element all the way down. When you're done with that element all the way down, if that did not go all the way down, whatever is in between, no need to execute it. That's lazy, right? Then start with the next one. Go all the way down. So in other words, it's called fusing. It takes all these methods in between and fuses it together. And that becomes one little function waiting. And then it just applies that one function on the elements, but only enough times. And as a result, it's very, very efficient. It's that pizza that I bought home, but I did not bake it yet. What does that mean? I can put more stuff onto it if I want to, right? And until I bake it, I can keep adding stuff to it. That's exactly what you saw here. You got a stream on your hand. You haven't committed the stream yet. And you can either now commit it, or you can continue to pass it around. And then you can come back and commit it later if you want to. So now you should start creating library of functions. So the 3 code that you saw before, had I called this function, what would have happened? All that work committed, right? And she says, here you go. And I ask her, what did you do? She says, done. All that work was done. She never cared to ask me if I want the result or not, right? But now that we refactored their code, what's happening? I call the function, she gives me a result. I say, what happened? She says, we got everything ready for you. Have you done any work? She says, absolutely not. Why? Because they're all? You say that in a very different way. That sounds negative. So we're going to pronounce it very differently. Because they're all very efficient. That's why you say it in Java 8, right? It's spelled L-A-Z-Y, but when you pronounce it, it's called efficient, right? And that's where you got the efficiency baked in, right? So look at the power of the stream. That's one of the biggest benefits you get out of this, is that it's very efficient. So we employ function composition to build on this. Very important for us to have a stateless behavior. You cannot pollute states in between. You cannot modify the state. Why can't I modify the state? Why shouldn't I cause changes along the way? Think about it. What will happen if I make changes along the way? Or what I cannot do if I make changes on the way? No, I cannot do something if things in the middle were changing. I cannot be lazy. I cannot be lazy. Why can't I be not lazy? Because if I was changing stuff in between, and she says, yep, we're here. Wait a minute, I don't see any results yet. What happened to all the results? Oh yeah, we haven't run it yet. Now this is completely confusing, right? How we cannot be, if you're eager, by the time I get to this particular point, oh, all that work has been done. But if it is pure, then we are good. Because it doesn't matter whether I do it now or I do it later. Laziness has to work hand in hand with immutability. Each of these concepts are really very heavily interconnected. You cannot think about them in isolation. You cannot be lazy if you had impurity. Imagine your boss says, work on this, and I need a report from you on the 1st of June. You know what? You could wait. You could start it promptly on 31st of May, like you normally do. But instead your boss says, I want this on 1st of June, but I want a report from you every week. Damn it, I cannot be lazy anymore, right? Why? Because there's a side effect. You got to release something every week, right? Am I making sense? So that's a big difference, right? You can postpone certain things, but you cannot postpone other things, please.
So if your sequence of processing streams has like 10 steps, and after the first step itself, let's say that the collection does not have any results, the other 9 is a waste. We could have stopped it at that stage.
So it won't even run it.
No, but if we had concrete results, we would have said if collection.size is 0, then we need not do any of the
So you are assuming the only person in this world who can do it is you. And they are not smart enough to do this.
So by postponing, aren't you undoing like unnecessary code which otherwise would not have been required to be executed?
Just think about this for a minute. Is it unnecessary code when you write all those if-else statements? Or is it unnecessary that you don't have to write it and the stream says, don't worry, I'll take care of it for you. So you removed all that intermediate silly if and else statements we would end up writing, right? You're saying, here's a bulk of operation. Do what makes sense. I'm done. That's called declarative programming. We have been doing this for a long time, right? We sit there and say, you know what? You guys cannot handle it. I'm going to provide every single detail. That's called imperative programming. That's how we talk to children, right? Sweetie, don't do that. I'll tell you every step to follow. You don't talk to an adult like that. You say, get this work done. And what does the adult do? Makes a decision based on what's right and wrong. So you don't have to waste your time doing all that intermediate step. Otherwise, what happens? Oh, first put in this collection. Hey, are you empty? Oh, yes. If you are empty, go this way. If you're not empty, go that way. 300 lines later. What are we doing? When this guy says, tell me everything you want to do, I'll decide what to go and where not to go, right? Think about which one is better for you. Do you want to sit there and specify every single step and feel good about it? Or do you want to say, that's the work I want you to do, Figure it out. I'm not going to waste my time doing it. That's a very different mindset. Yep.
When you filter the...
Go ahead. Fire away. Yeah, I can hear you.
So when you filter the stream and transform it, and you don't do a collect at the last,
Yes.
then what happens to the rest of the data that is still hanging there?
There's no hanging at all, because it's the collect that triggered the chain. Until the collect was called, nobody left the platform. The train is in the station, and the path has been decided, but you never told where to go. The train says, I'm not leaving.
So there's no question of garbage.
There is no garbage to collect, because the train has not even left, right? The end point triggers the source. You never call the end. The source was never used. That's the efficiency, right? And that's remarkable, isn't it? It says, you tell me where to go, I will start from here. If you never told me where to go, I'm waiting. That's called lazy. So that's why it never triggered any of these.
Correct the only endpoint method or other?
A lot of destination trigger methods. Yeah, absolutely. Huh? I don't write bugs, so I don't know the answer for that. Well, we assume that these are hard to debug, right? But we've been debugging code for a long time. This is no different from that. You can put breakpoints, you can step through it, as long as... So you want to debug in production. You and I have to have a very long talk. Okay, so, yep, go ahead, fire away. Does it? No, it doesn't. Actually, it's a time complexity is exactly the same. No more, no less.
Lazy reading or lazy iterating over the list or the collection. So you have to do some filtering on each collection element. And if I'm doing it lazy, so wouldn't that increase this?
Why? Answer the question why. Think about it. Why should it be more? Right? You are writing if-else statement. That is eager, which means you're saying, I don't care whether you need it or not. I want you to do it now. This guy says, I'll skip over a lot of stuff you don't care about. It's actually going to be better in that regard. So at the worst, it's the same. At best, it could be less. Yeah. Yes? No, this is purely sequential, one at a time. But it does it only when it's needed. Right? If it's not needed, it's not going to do it.
Why do they say that synchronously parallel processing, say for example?
If you want to make it parallel, you can make it parallel. It's not going to run parallel just because you write it sequential. Yeah? So you can decide whether you want it parallel or not. So for example, in this case, you're saying, oh, you know what, I want to go through each one of them and process that. So you can run through it, and in this case, of course, you're going to collect the result in the very end and put it back into the destination, right? So notice in this case, I am running it sequential. That's all it is. Just to entertain the thought that you asked, just for fun purpose, let's say try thread.sleep 1000, and I'm going to say catch exception, and let's say in this case, just put that in there. So I'm going to come back here, and what am I going to do? I'm going to run this. It's taking some time, isn't it? Because it's got to go through, and I slowed it down because I put a thread.sleep. You saw that happen, right? Well, then you realize, you know what? This is all pure functions. There's no side effect. So I say parallel stream. So now I've turned it into parallel stream rather than being sequential stream. There you go, how fast that was. Because I'm running concurrently. You cannot even imagine doing this if you were doing it with a loop with a mutable variable, right? So it makes parallelization extremely easy, but you got to still say you want it parallel rather than being sequential. So that becomes very, very easy to run once you ask it what to do. So that gives you an idea about how this can go through. So we want to definitely make sure these functions are pure. So let's talk about these specialized functions. What do these mean? The first thing is filter. I want you to think about filter. What does filter do? If I have these elements, filter only talks to one element at a time, right? Do I select this or not? Do I select this or not? Do I select this or not? Making sense? So for example, I have wonderful people here on the front row, and I'm going to apply a filter. I'm going to say, I want only people in the front row to stand up if they are older than 100 years old. Anybody? Takers? Not anybody, right? But what did you do to decide if you're 100 years old or not? What did you do? He just checked his own age. Too bad you had to actually check. Right? He checked his own age. Did you kind of look around to him and say, how does this dude look? Did he do that? No, right? He was not doing any profiling, right? He just minded his own business. That's exactly what filtering is. Make sense? So he simply said, I care about me, my own age. I don't care about anybody else around me. So far, so good? So that's what filter does. So a couple of rules about filtering. If you take n elements and you apply a filter, it's possible you get 0 elements, which is what we just got, right? Because nobody was older than 100 years here. It's also possible you will get all the elements. For example, if I were to say, hey, in this front row, I want everybody to stand, but where they are older than 1 year old, right? And that's going to be everybody. So the range of value is going to be either 0 or n or anything in between, right? Make sense? Now, on the other hand, let's look at a map. A map is a transformation. So what does a map do? Takes every single element and transforms to something else. So I got 6 people here. I'm sorry, with all respect, 9 people, I don't care about them, but all I'm required to do is collect their names. So I'm going to ask for a mapping of their names. Once again, what is he going to do? If I say, what's your name, what are you going to say? But it depends on who's asking, right? If a cop asks, he gives a completely different name, right? But he only looks at his own name, right? That's what you do, right? He doesn't still look at the neighbor and say, what can I give the name? He only gives his name. That's all he's caring about. Well, what can we say about a map? Well, remember, a filter could be 0 to n elements or anything in between. However, a filter produces a subset of the values. Do you agree? If I say, among the people here, I want only people who are older than 1 year old, and what should I expect in this list? Either all the people in this list or a fewer than those people, right? But if I say, among all these people in this, I want people who are younger than 1, I would be really ticked off suddenly if I see him in the list. It's like, where did you come from, right? He's like, I just sneak in. And I suspect him for doing it, right? So the point is, your filter would never give you an arbitrary element. It's always a subset. Agreed? Map, on the other hand, the number of input is equal to the number of output. Is that true? If I have 6 people, if I ask to collect the names, how many should I expect? 6, assuming there are no nulls, and we'll normally don't talk about nulls. We don't want a person with a null name. That's really sad. Why do you even say these things? Okay, so you have, that's really odd, right? Son, what's your name? Null. What are you thinking, right? Okay, so we got 6 people. How many names do we have? 6. What is the type of the input? Person. What's the type of the output? String, collection of string. So map preserves the cardinality, but map guarantees nothing about the type. It could be the same type, could be a different type, which is what we saw here. People came in, but what went out is their names, right? So filter, so now think about a filter as a cone. Think of a map as the bottom of the filter, right? You see a funnel or a cone, and it comes like this, and there's a pipe, right? You could cut off the pipe, that could be the map itself. Or you can cut off the bottom, that's a filter alone. Or you can put them together, you got a filter and a map. But then comes along this wonderful thing called a reduce method. What does a reduce method do? The reduce method is wicked. The reduce method says, well, the filter goes like this, right? The map goes like this. The reduce says, I'm going like this. Like, for example, I'm going to total the age of everybody in the front row, starting with him. You should see the stare he has on me. I'm not going to ask for your real age. So I'm going to ask them to total their age. How do I total their age? With immutability. Well, here's one way I can total their age, right? I can take a 0, and what's 0? 0 is the age of everybody we know so far. And I put 0 on a post-it note and I give it to him and say, here you go. And what does he do? He takes his age, adds it to the 0, and that becomes a new age, correct? And he then passes it down to her. And what does she do? She takes the age given to her, totals her own age to it, right? And passes it down to him. Now at this point, what do we have? total of the age, everybody to his right. We can repeat the step. He takes his own age, adds to this carryover total, running balance, if you want to call it that way, and passes it down. Am I making sense? Finally, you get to the age. What do? Now you have everybody's age to your right. He adds his own age. We're not done yet, right? And then we have one more pass through. What does she do? She gets the age of everybody to her right, takes her own age, subtracts 10 from it, adds it to the result, right? Am I right? She's like, yeah, how did you know, right? And then I get the value out here. So the point really is, now notice how we are working through this, right? We take the value and the value ripples through, but rather than going horizontally, right? But look at what he did before. He looked at his own age. He looked at his own name. But now he's doing something a little different. He gets something from the right, does a little math, and sends it to his left. So now we are going horizontally rather than going vertically. And that is exactly what a reduce method is doing. It is combining, cumulating it. Now you may have used this in multiple different languages. For example, this is called reduce in Java. If you programmed in Groovy, anybody programming in Groovy? No, nobody? I thought a few hands went up, okay. If you're doing Groovy, you call this as an inject method. Anybody using Scala? A few hands. You call this fold left, for example. Anybody using C#? It's okay among friends, you can raise your hand. They call it aggregate. Look at the beauty. Reduce, inject, fold left, aggregate. What's going on? Well, the language authors, when they start creating this, they call all other language authors and say, what names are you using? I'll make sure I don't use it, right? So basically the idea is they're all really the same. We just call them different, right? But essentially the concept is the same, and so that's what we call it. That's a reduce method. But that's a very generalized reduce method we are actually using here. So let's see how we can use that here, for example. So I'm going to go to the stream of all the people, and I'm going to say, well, reduce, first of all, map, and I'm going to say person get age. So tell me what I did so far at this point. I transformed from the people to what? Their age. But I haven't done any work yet, right? But it's a transformation that's just hanging in the air, not committed yet. But I went from people to age, which is really nice, because this is privacy. I wouldn't know whose age is what, because all I have is people's age, and so it's pretty safe for you to just give the age. You don't have to really go through that complex math, right? And because nobody knows what your age is, because we only have this age value that we have on our hand. Then I can say, all right, dot reduce, start with a 0, and then what? I'm going to say running balance, carry, and age, and return from it a carry plus age, right? That is the result of it. When I'm done with it, I can say total age. But I got to store it, so I'm going to go back here and say int total age equals. Make sense? Last time I tried it, one guy got very angry. He said there should be a long and not an int anyway, right? So you can run through it, and that happens to be 212. That's the total age of everybody in this collection. So you can see how we went from stream, map, and filter. However, I'm going to say, let's do this a little differently. Dot filter, given a person, person dot get gender is equal to gender dot male. This is the total of age of only the male in that collection. So we did a filter, map, and reduce. Now big data, what do we normally do? We do map, reduce, filter, right? This is a gather, scatter algorithm. That's what we're doing in this case. So we are saying, given this collection, only get me the male, among the male get me their age, and once you got their age, simply total it for me, right? And so we are beginning to say these as transformations to perform this operation. It becomes a lot easier to express it. So we saw all the three: filter, map, reduce. So you can go either vertically, work with individual data, or you can go horizontally. What about parallelism? You asked about parallelism a few minutes ago, right? Parallelly filter, right? I mean, to know whether you are older than a certain age, I don't have to wait for that when I can determine his, right? Everybody here can concurrently decide what their age is. You don't need to know what your next person's age is to decide yours, right? So as a result, you can concurrently do that. So I could be either parallel or sequential. What about mapping? Mapping can be concurrent also, right? Filter can be concurrent, map can be concurrent. Reduce, on the other hand, it can be semi-concurrent. You could probably say, let's just total in part, bring them together. Like a tree structure you potentially could do if it makes sense, but it also depends on whether it's associative or not. Not all algorithms are associative. So there's a difference between can I and should I. Just because you can parallelize doesn't mean you should parallelize. This kind of goes back to your question, hey, could I not parallelize? That's a decision you have to make. It's easy to parallelize, but you got to still decide it. When should I parallelize? When should I not parallelize? Well, let's say I'm here, and if all I want to do is come over to the person in the 7th row, the easiest thing to do is for me to walk over there. The really bad way to do is to ask somebody to bring my car over so I can go see him, right? That's going to be really a long time for my car to drive up over there. But if I'm going to go 10 kilometers from here, okay, Bangalore is the wrong place to give this example. It still probably is faster to walk. But in a city where there is actually more civilized traffic, I mean, it's a lesson I've learned over time, right? I've learned that if I ever want to leave Bangalore, I should leave before the locals wake up. I always get to the airport in 30 minutes. And then if it is in the evening, I definitely know I'll get to the airport before the next morning. Because in the worst case, I can just wait until the morning, right? So that's kind of what I've learned over the city's traffic. But the point really is, if it's a distance I have to cover, then I want a faster transportation. If it's a shorter distance, like a few feet away, I don't want to use a transportation, it's easy to walk. Much like that, if your task is really fast, or if your data size is really small, you would be wasting time going to multi-threading compared to sequential. If either your data size is big, or your task is slow or long-running, then you would benefit by going concurrent. In other words, the context switching time should be relatively small compared to the time of computation. If the time of computation is very small, your overhead is very more, relatively speaking, right? So that's why you have to make the decision. But once you make a decision, you can flip a switch, and you can either go concurrent or sequential fairly easily at that point. So given this, you want to be able to go through and figure out which one to use. There are some really good specialized functions. Like you could use a function called sum rather than going through the methods we saw. You can say max and min, you can count the number of non-adults, for example. Let's do the count for a minute. So here I'm going to say non-adults. What does that really mean, non-adults? So I'm going to say count, and I want to display the count over here. But in this case, I'm going to say stream dot filter, and what am I going to say? Given a person over here, dot get age, and what am I really looking for here? I'm asking for non-adults. So what is a non-adult? So that is less than 18, right? And then what do you do after that? Dot count, and you can ask him to give you a count of that. How many do we have? Oh, possible loss of data. Whoa, okay, long. So 2 non-adults, right? In this case, of course, whether it's an adult or not, we base it based on the age, not maturity, right? So that is an example of how we can do that. Well, streams themselves have some characteristics. The streams have this characteristics of whether they are sized or not sized. What does that mean? A stream could be infinite in size, which means it's lazy evaluation. It's not really created them. That's one way to do it. We could also do, it could be an ordered or unordered. When would it be ordered? When would it be unordered? If we went to a list and asked for the data, it is ordered stream. If we went to a set and asked for a stream, it's an unordered. So the source can decide this. You can also perform operations in between to change this also. It could be distinct or non-distinct. If it's a list, it will be non-distinct. If it's a set, it will be distinct. So that's how it will be deciding what the flavor is. It could be sorted or non-sorted. If you have sorted hash map, I'm sorry, a sorted set, then it's already sorted. Or you call sorted on it, it becomes sorted. So these are the 4 different properties, but they could vary depending on the source you start with and the operation you perform. But I want to stop with one last example because I see this example used so many times, and I think it's a really terrible thing to do. And if we can learn not to do this, I think we are better. So I'll end with this one example. And the example I want to end with here is the wrong way to do stuff. And then I'll give you the right way to do it. Let's say I want to take all this collection of people, and I want to really put maybe people who are older than 18 into another list. So I'm going to say over here, list person older than 18 equals new array list. So I create an array list. Then I say stream dot filter given a person dot get age is greater than 18. You would argue this is functional style, isn't it? Up to this point, it is. Then I say for each, and what am I going to do? Given a person older than 18 dot add person. Then I come here and say output over here, and what am I going to output in at this point? So this time I'm going to say output older than 18. So if I run this code, I got everybody who's older than 18. What is wrong with this code? Anybody? What was it? No, what is wrong, not what is right. What is wrong? Mutability. I mutated the global variable in outside scope, right? What is this mutability? What is the smell of mutability? What is causing mutability here? One word. Add. Add is causing the mutability. What is wrong? Why shouldn't I mutate this? What will be the problems if I mutate? What will be the consequence? If you ever turn this to a parallel stream, what's going to happen? Concurrent modification. And what's going to happen because of that? No, not an exception. What was it? Unpredictable. What's going to happen? You have all these people, you turn on parallel, you come to the end, and you say, where did Bob go? Oh my God, we lost him. Right? Is that going to be the case? You got 2 requests coming in, one writing on the other, bad things happened, right? So you got to go to the other side and you have to do an inventory count, right? Did everybody come today? Sorry, this time we lost Bob. We should try a better way next time. And every time this happens, where we start losing data. How do you make sure that doesn't happen? Well, you go back to line 22 and say, let's put a concurrency synchronization on it. What do you think of that idea? We take this beautiful solution and totally mess it up. Right? And then the code becomes stinking after that. Yep.
Here the for each is the endpoint.
Here the for each is the endpoint. But doesn't matter. You could be mutating anywhere in between too. Mutability is bad. So, yeah, it is. So during the pipe, you should not mutate anything. So a better way to do this is, instead of doing the for each, you want to say collect, and you want to say to list, and you want the list to take care of that for you rather than you mutating it. Then you remove this part and say equals, and you are getting the same result. But the beauty is this: the collect will take care of it. And I'll leave with one thought for you. You may say, wait a minute, what does collect internally do? Can you take a wild guess? It is mutating. You say, wait a minute, if they are mutating, why shouldn't I mutate? Good question, right? I'll tell you the reason for it. If you mutate, correctness is your problem, correct? Complexity is your problem. Concurrency is your problem. Maintaining the code becomes your problem. If they mutated, every single one of them becomes their problem. Lesson in life: you always make things other people's problem. Right? If you don't do this, you don't have to maintain it, right? So they deal with it. We can sit back and say, I've done my part, give me the results. And that makes our life a lot easier. We can get better performance, they can do the optimization, we don't have to worry about it. We got application to release, they can work on improving the infrastructure, we can benefit from that. This is the whole point about having a JVM, right? So we can leverage that benefit and develop applications with it. That's the power of the stream. I hope you found it useful. Have a wonderful evening. Thank you.